Welcome, my friends, to the first official bug fix edition of Creating Electronic Music with ChucK. In the last tutorial, we used a subclass of a ChucK graph to implement a fully featured synthesizer voice. The fact of the matter is, that ChucK script was complicated enough that what we're really doing here is writing software for ourselves to use in the future. And as we all know, software has bugs, and I wrote one. I thought about replacing the video with a fixed version, but then I thought, why not be more transparent than that and just walk you through the fix? If you followed along with that tutorial, you saw that I made a filter envelope, and later I made an LFO. Here's the code for that LFO. The problem here is that the LFO forces the low-pass frequency to be the filter cutoff value plus the LFO value, and that does not take the filter envelope into account. This means that our LFO always forces the low-pass frequency to what it wants, and the filter envelope is ignored. I stared at this problem for quite a while until finally radioing for some help from my friend Alex Novak, who is a software engineer. He asked the very pertinent question, does this LFO need to be on its own shred? It seems like you just want to add the filter envelope and the LFO together. And it turns out that's totally true. The physical design of an analog synthesizer, which has an LFO that's always running, led me down a path of thinking that the LFO needed to be running in its own shred, but that's actually not the case. The LFO only needs to advance when time is advancing in our Synthvoice more generally, and its value only needs to contribute to whatever the filter envelope is doing. So I pushed up a fix to GitHub, and I made a new branch with a pull request. A GitHub pull request is a way to propose a change to a file. Here we can see mine. If I click on it, we can see that I've written a note describing my changes. Up here, you can see a commits tab and a files change tab. If this was a complicated change, you might see more than one commit on this tab. A commit is a way to express a particular state of the codebase as you gradually change it. The way I like to think of commits is this. When I play the game XCOM 2, I very frequently save my game because that game is so randomly and punishingly hard that I frequently want to get back to a known good state. A git commit is like a saved game, or that's how I think of it anyways. This particular change is very simple, so there's only one commit. If we click on that commit, we can see the diff view. On the left side of the diff, we can see what the code was before the commit. On the right side, we see what it will look like after the commit. So you can see here that I've removed the process LFO function because it was not needed. Instead, I've just added the filter LFO's last value into the calculation of where the filter envelope should be at any given moment. This fixes the bug, and as a side effect, we no longer need to have that 10 milliseconds at the beginning of the filter envelope, which is great because I never really understood why I needed that thing. Now, if I was committing code to a shared project, somebody else could see this and review it. They can make comments and ask for changes if they see something wrong. In my case, I'm the only one in this code base, so I'll just jump over to the Conversations tab and hit that green merge button. Now, if you go to the GitHub repo, the fixed file is what's shown. I've been looking into live coding options, so hopefully we can talk about that next time. Or maybe I'll just find some more bugs.